Now let us look at transactions in EJB. A transaction is nothing but set of instructions executed as a single unit of work. For example, if you look at your database side, you issue commands like select, delete, insert, and at the end of it you will specify the commit or the rollback. So this, till I specify a commit or rollback, it's one transaction. So how do I work with transactions and what are the properties of transactions is what we are going to cover out here. First of all, there are 4 properties of transactions called as the ACID property. A stands for atomicity, consistency, isolation, and durability. Atomicity means the entire thing gets committed or nothing gets committed. So everything is treated as a single unit. Consistency means at the end of my transaction, the data is at a proper state, for example, or the required state. For example, let's say balance value cannot go into a negative. So at the end of my transaction, the value of balance will not be negative. But of course, during the transaction period, it can be. But at the end of the transaction, when I commit, it should be at a proper state. Isolation. Isolation means whatever one is doing, the other should not see. This is nothing but the transaction isolation levels that we spoke about during JDBC as well. If, let's say, one person is making a change to the record and has not yet committed, the other person should not be viewing, should not be able to see those changes. Durability. Either everything gets committed or nothing gets committed. If suppose I am working with multiple databases, either I commit all the work to all the databases or none of them will get to commit. That is durability. So these are the 4 properties of transaction. In a transaction, we have a transaction manager which manages the transactions. We have a resource manager. Resource manager is nothing but your driver which manages the resource. Resource is nothing but your database itself. So when you create a transaction, when you start a transaction context is created within which all the transactions, whatever you do within the transaction occurs. So any rollback occurs within the transaction context, everything, all the work that you have executed within the transaction context gets rolled back or committed. There are different types of transactions. For example, we have a flat transaction and a nested transaction. Flat transaction is the only type of transaction which is supported by the servers and the specification. Nested transactions is not supported. A flat transaction is where either everything gets committed, the entire work is treated as a single piece where everything gets committed or nothing gets committed. In a sense, let's say for example, I want to book a ticket from here to Bombay, Bombay to London and London to New York. Let's assume I get a ticket from here to Bombay, Bombay to London, but London to New York, I do not get the confirmation. So, in a flat transaction, the entire thing gets rolled back. Whereas in a nested transaction, I can confirm from here to Bombay, Bombay to London. From London to New York, we can look at other alternatives and confirm from there. So, you can partially commit the transaction, and another part of a transaction can be committed in a different route. So, that is a nested transaction. So, we have seen the types of transaction, the properties, and what are all involved in a transaction. What are the different ways of handling transaction? One, container managed transaction. 2, bean managed transaction. Otherwise known as CMT and BMT. A container managed transaction is also known as a declarative method, whereas a bean managed transaction is a programmatic method of handling transactions. CMT can be made use for all the different types of beans. Your session beans, entity beans, and your message driven beans can make use of a container managed transaction. But the bean managed transaction can only be used by session beans and message driven beans. Entity beans cannot use bean managed transaction. It is the container which has to handle transactions for entity beans, let it be a CMP or a BMP. In case of a container managed transaction, since it is a declarative method, we need to declare the transactions when we want to begin a transaction, when we want to end another transaction to the container via the XML file. While we were looking at the entity beans, we saw the assembly descriptor with container transaction element specifying the method name and the transaction type. What we saw out there was nothing but a container managed transaction declaratively being specified in EJB jar.xml file. So, when you work with a CMT, there are 6 types of transaction attributes. For a CMT, they are 1, required, 2, requires new, 3, supports, 4, not supported, 5, mandatory, and 6, never. These are the 6 transaction attributes for CMT, which tells the container when to begin a transaction and when to end a transaction. Now, let us look at the explanation of each. We specify these transaction attributes for the methods. For what type of methods? For the methods of the remote interface and the home interfaces. The required attribute, when specified for a method, works as follows. Let us assume I have method A which calls method B. Method B has been declared with the transaction attribute required. Let us assume that method A is not under a transaction context and calls method B, which has been specified as required. So what happens is, because it says required and it needs a transactional context, a new transaction context is created within which the method B gets executed. So you will have a transaction manager managing the set of transactions. So we get a transactional context here. This is a transactional context. Let's call it as TC1. So when A calls B, since B requires a transactional context, B gets executed inside this transaction context. If any error occurs within B, it rolls back within this transaction context all the work that B has done. Let's assume I have method A, which is in a transactional context, and calls B, which has been specified with required. In that case, B has just says that I require a transactional context. So if it is already existing by the method which is invoking B, then it also belongs to the same transaction context. It means to say that there is already a transactional context within which A is getting executed, and A calls B, which also has specified required, so B also executes in the same transactional context as that of A. So let's say A has executed some work, and then B, while executing certain instructions, gets an exception and calls a rollback. So the entire work that has occurred till now, whatever A has done as well as B, the entire thing gets rolled back, because it's in a single transactional context. That is how required works. Now let's look at requires new. With requires new, let's assume A is not under a transaction context, calls B, which has been specified with requires new. It means to say, if there is no transaction context, I still need a transactional context, so it creates a new transactional context within which B executes. But let's assume that A is under a transaction context, B says requires new, so it means to say, regardless whether I have a transaction context or not, I want a new context to get executed within. So a new transactional context, let's call it as TX2, is created, which means to say that if already A was under a transactional context, let's say TC1, still because B has been specified with requires new, another transactional context, let's call TC2, is created within which B executes. So now if B, while B was executing, if any exception occurs, then the rollback occurs only in this transactional context. It does not affect A's transactional context. This is about requires new. Now moving on to supports. Let's assume that A is not under a transactional context, calls B, which has been specified as supports. Support means to say, if there is a transactional context, I'll come under it, otherwise I do not bother, I do not need a transactional context as a must. So therefore, there is no transactional context for B as well. But if A is under a transactional context, calls B, which says supports, then B is also under the same transactional context. Moving over to not supported. Let's assume A is not under a transactional context, calls B, which has been specified as not supported. B also does not have a transactional context. If A is under a transactional context, calls B, since B has been specified as not supported, it means to say, even if the transactional context is there, I do not want to come into a transactional context. So therefore, B does not have a transactional context still. Mandatory. If A is not under a transactional context and B says it's mandatory, it means to say it must get the transactional context. It will not create one if it is not there. So therefore, you get an exception. But if A is under a transactional context, calls B which is specified as mandatory, so B is also under the same transactional context. Let's look at the next one, that is never. In case of never, if A is not under a transactional context, calls B, B has been specified with the attribute never, B is also not under a transactional context. But if A is under a transactional context, calls B, and B has been specified with never, it means whoever is calling should not be under a transactional context. So if there is a transactional context, you get an exception. So this is the meaning of each of the transactional attributes which you use in case of a CMT. As we mentioned, this would be specified for every method. If you do not specify a transactional attribute for a method, automatically the server applies the transactional attribute supports for the methods. Now, if you go back to the example that we looked at, where we mentioned method name star, that star means all the methods. You can specify for each of the methods by specifying a method name. When we don't specify which interface methods, then it's for all the interface methods. If you want, you can specify method-intf tag. In this tag, you specify the value as either remote or home, or you can say star again. So thereby segregating the remote interfaces and home interface methods. Another question out here would be, what if I have overloaded methods, the same method names, then how do I declare different attributes for each of the methods, although it's overloaded? Of course, when you specify the method name, within that method name tag, you can specify params tag also. So you can specify what type of parameters that particular method would be having, and then assign the attribute for the method. So therefore, you can specifically give different attributes for even the overloaded methods. So this is how you declare transactions declaratively or in a CMT methodology. Now let us look at programmatic method of handling transactions, that is BMT. There are two ways of handling transactions programmatically, that is, one, using JDBC, two, using a JTA, Java Transaction API. If you use JDBC, then of course to end a transaction you just call commit to, or you specify rollback. In case of JTA, you need to make use of user transaction interface. This is available in javax.transaction.userTransaction. If you use JTA to code for bean managed transactions, then what you need to do is, remember you have your context object. take your session context or the message driven bean context. Remember, you cannot use this for your entity beans. So take your session context object and call the method get user transaction. This will return the user transaction object. Now using the user transaction object, you invoke the method begin to start a transaction, followed by you issue whatever the commands you require to get into that particular transaction, and to end it you call either commit or rollback using the user transaction object. Do not while working with JTA call JDBC's commit, that is the connection object of JDBC's commit and rollback, and while using JDBC do not call JTA's commit and rollback as well. Using this user transaction, you also have one more method called getStatus, which returns what is the status of my transaction right now. Like you can find out whether it's getting ready to commit, or the transaction is not there at all right now, or the transaction has been committed, or whether it's rolling back, etc. So there are about 11 to 13 statuses that are available as constants. So once you call for getStatus, it will return an int value. You can compare it with the constant and find out what is the status the transaction is at. So this is how you can use JTA to programmatically work with transactions in your session beans or message driven beans. The difference between container managed transaction and bean managed transaction again is the point at which it's going to start the transaction. In case of a CMT, the EJB object itself, at the point of EJB object itself, the transaction starts. But in case of your bean managed transaction, it's only in the bean where you start your transaction and end your transaction. So the point of starting the transaction differs between your CMT and BMT as well. A client can also begin a transaction using a JTA methodology. If the client program wants to begin a transaction, then the client has to look up for the transaction, and further down as usual, how we have specified here, it has to continue. In other words, for a client to get a user transaction object, it uses the JNDI context object dot lookup of javax dot transaction dot user transaction, downcast this to a user transaction type, downcast this to a user transaction type, store it into a user transaction object, then invoke the begin method, execute the set of work, and finally call the commit or the rollback. Now in case of a BMT, due to some exception or whatever the condition in your program, you can always call a rollback. But in case of a CMT where the container is handling a transaction, if some system exception occurs, the transaction will be rolled back by the container. But if for some reason in your code some exception occurs, how do you tell the container, or due to some condition in your work, how do you tell the container to roll back a transaction? because remember here the container is handling a transaction. Container will not know your conditions due to which you want to roll back a transaction. In order to specify to a container to roll back a transaction in a CMT, you have a set rollback only method in the context, in your session context or entity context or your message driven bean context. So you invoke this method, which is basically suggesting the container to roll back the transaction, due to which the container will then roll it back. Another problem that appears during transaction is that in case of a BMP or a CMP, where you are going to handle it via container managed transaction, if you suggest the container to roll back the transaction, the container will roll back the transaction, which means to say whatever you have done is not going to affect the database. After rolling back the transaction, it will also call for EJB load method, because remember during this transactional period your bean instance variables were changed. Now if you have rolled back a transaction, the value of the database and the value of the variables in the bean are totally different, two different values, because the bean consists of the changed values, whereas the database the change has not occurred because of the rollback. So the container will call the EJB load method, which is a callback method, using which it will update the variables. Your session beans as well can code for database connectivity. But in case of your session beans, which can do a persistence using the JDBC code, if suppose it is applying a container managed transaction and you suggested the container to roll back, now in your stateful session bean, remember you have your instance variables to which you have made the changes. Now if you have suggested the container to roll back, the entire transaction is rolled back. So again the database is not updated with the changes. The variables again in your bean, stateful session bean, are having the changed values, whereas your database still has the old values due to the rollback. But the container has no way of calling to some method using which it can update back your instance variables. There is no callback method like EJB load, which we had for entity beans. So how do you make sure that whenever this rollback occurs, the variables, instance variables, are updated with the data which is there in the database? To achieve this, for your session beans, there is an interface called session synchronization. This has methods, three methods: after begin, before completion, and after completion. This after completion takes a Boolean value. Now what you do is implement the session synchronization on your session bean and implement these three methods of session synchronization, which are nothing but callback methods for your transaction. So when you implement these methods, in these methods you can implement your JDBC code to read back the data from the database and apply those results to your variables. Of course, after begin will get executed right after the transaction has started. Before completion will get executed just before the rollback occurs or the commit occurs. Just before the rollback or the commit before completion gets executed. After completion gets executed, right after the commit or the rollback. So, to solve this problem that we were talking about, that is, when you are handling with container managed transaction, for a stateful session bean, working with the database to persist the data, and you have called for set rollback only, suggesting the container to roll back. The container rolls back the transaction, but the information stored in the instance variables are different from the state of the data in the database. So, by implementing the session synchronization and their methods, you can achieve or you can solve this problem. What you do is, you implement inside your after completion, you check for this Boolean value. What the container does is, if there is a rollback, it will make a call to this after completion method by passing false. If there was a commit, then the after completion will be called with a true value being passed here. So, you check inside this method, if this Boolean value is false, then go back to the database, read the content from the database, update it to the variables. So, that is about session synchronization, and that ends with transactions. Next, let us look at a situation where a client, let us say, is working with a shopping cart. He is ordering certain products, and in between he wants to stop and later continue from where he left off to order the rest of the products. Now, in order to achieve this, the client needs to store the state of the object so that he has access to where he left off, and then he can continue with that same state later. So, in order to achieve this process, you have something called as handlers. You have an interface called handle and home handle. Handle is a serializable object for EJB object, whereas home handle is a serializable object for the home object. Why do we have this? Remember, the home object and the EJB object both are residing at the server. If you want to take their state and store it at the client machine, remember, not at the server, you are going to store it at the client. So, you cannot just take the remote object reference or a home object reference which the client has and serialize it, because it does not actually hold the state. The actual state is held at the server side with the home object and the remote object. So, what you need to do is, using your remote object, you call for get handle method. Now, you never declared a method called get handle in your remote interface. Where is this coming from? Remember, your remote interface extends from EJB object. EJB object interface has this method get handle. So, this returns a handle type of object, which is nothing but a serializable object of the EJB object. So, this object you take and serialize at the client end, that is, store the state of this particular object, which is nothing but a state of the EJB object in return. So, now to store the state of an object, again go back to your serialization concept. You take your object output stream, so if you want to store it into a file, you pass the file output stream. passing the file name, and then store the object os dot write object of h. This will serialize the home object, this will serialize the handle object, which is the serializable object of EJB object. At any point you want to retrieve back the state, so you can continue from there. What you need to do is create an object input stream passing the file name, call the read object method, downcast it to a handle type, and now using the handle object you invoke the method get EJB object, store it into a remote interface reference now. This is how you store a EJB object at the client side and retrieve it back. If you want to do the same thing for the home object, then using the home interface reference, invoke the method get home handle. This will return a home handle object. Serialize the home handle object, which is a serializable object of the home object. Once you have serialized and you want to retrieve back, then of course you need to downcast it to a home handle type. And using the home handle object, call for get EJB home. It will return back the EJB home object so that you store it back into a home interface type. This is about serializing the EJB object and the home object at the client side. Now let us look at the next concept that is called as local interfaces. Local interfaces were introduced in EJB 2.0. Now let's assume that I have a container which has bean 1, bean 2, bean 3. Let's say I have another EJB container which has bean 4, bean 5, bean 6. I have a client. It could be either your Java client or a HTML client, which is a servlet or a JSP. Now let's assume this B1 can be called by a client. It can be called by B4. B4 can be called by B2. It can also be called by client, so on and so forth. Now let's assume at any point B3 will be accessed by either B1 or B2. It will not be accessed by any beans in this container nor by a client. By defining this bean 3 as a remote object will lead to a lot of networking calls, or rather the RMI calls, which will reduce in performance because it's an extra effort. If you know that a particular bean will not be accessed away from its container, then you might as well define such bean as a local object by deriving it from a local interface. Similarly here, let us say B6 will not be accessed away from its container, that is, it will either be accessed by B4 or B5 or any other bean within this container itself, not by beans in this container nor any outside client. In that case, bean 6 can also be defined as a local object by deriving from local interface. This was introduced to reduce the network traffic, therefore increase in performance. So, you have a interface called local and local home. So, the home interface which you derive for a local object will be derived from local home instead of EJB home, and the interface will be derived from local. The interface with the business methods will be derived from local instead of EJB object, and the methods therefore of both the home interface and the interface do not have to throw remote exception because they are local objects, and the method of the home interface, like the create and the finder methods, will have to throw only the create exception. One more change is that when you are defining it as a local object, the handle interface does not come into picture. The get handle, get home handle methods do not exist in the local or local home interfaces, because it is not a remote object for a client to serialize. The client first of all cannot access these local objects. So, there is no question about having to serialize it remotely by some client. So, therefore, there is no handle or home handle interfaces defined for this, local interfaces. When you are defining a local object in your XML file, instead of specifying the home and the remote tags to define your remote interface and the home interface, you will use the tags called local and local home elements to define your home interface and the interface names. In what situations would I use this? For example, let us say whenever you are writing entity beans, generally entity beans are not given access to the client, because every method call will cost you on the network traffic and bring down the performance. So, what we generally do is, in enterprise applications, we write a session bean. The client always accesses to the session bean methods. The session bean methods in turn accesses to the entity beans, or even probably to other session beans. So, at any point, if a client is going to access one particular session bean and that session bean in turn will access your other beans, this particular design pattern is known as a session facade. So, by creating a session facade, you are reducing on the network traffic, and the client will always call to this methods of the session facade, which is nothing but usually a stateless session bean, which in turn accesses your other beans, let it be an entity bean or your session beans. So, in such cases, you know that you are not going to access these beans from outside the container, EJB container. So, you might as well define these beans as local objects. Now, let us look at message driven bean. Message driven bean, we said, was introduced in EJB 2.0. It is nothing but the concept of JMS, that is asynchronously receiving messages. Let us go back to JMS. We have a sender of a message. We have a mom server where the destination object is residing. We have a receiver who receives the message from the destination object from mom server. Message driven bean is always written as a receiver. But of course, that's not a restriction. A message driven bean can also send a message. We'll look at that little later. So a message driven bean must be a receiver regardless. Even if he has to send a message, it has to be a receiver no matter what. So therefore, this is a MDB here, our message driven bean. The question now is, can you write any business methods in a message driven bean? Can any client access the business methods of a message driven bean? The whole idea of message driven bean is just to receive asynchronous messages, which means there is no client accessing a message driven bean. If there is no client accessing directly a message driven bean, there is no home interface and remote interface for a message driven bean. So there are no business methods for a message driven bean. The only thing that you write for a message driven bean is the bean class, and the bean class will implement the message driven bean interface as well as a message listener interface, as he is a receiver of the message, and it will implement the on message method of the message listener. So you implement the on message method of the message listener interface within which you process the message. If at all the message driven bean wants to send a message to a destination object, it has to do it through the on message method itself. Again, if the message driven bean wants to send a message, it needs to write all the JMS code, that is, get the connection, look up for the factory, get the destination object, get the session, and publish the message. Since the message driven bean, while sending a message, refers or looks up for a resource, you will have to have a message driven tag declaring a resource ref, specifying the name of the destination object and the factory in ejb-jar.xml, and similarly map the resource ref name with the JNDI name in the WebLogic ejb-jar.xml file. Now let us take a look at an example of a message driven bean, and just before that we will first look at the life cycle of a message driven bean. The life cycle of a message driven bean starts at does not exist state. A new instance is created, set message driven context method is called, and EJB create method is invoked, and it is pulled. When the message hits the destination object, it moves into a ready state and it gets the on message method invoked, and it moves back to a pulled state after the on message method. Once you call EJB remove, it moves from a pulled state to a does not exist state and calls the finalize method. This is the life cycle of a message driven bean. Now please note that in case of a message driven bean, when the message hits the destination object, the EJB container will allocate one instance from the pool to process the message. For every message driven bean, there is a separate pool of instances.